Scientists, for whatever reason, are often depicted as aloof, quiet, antisocial, just all around not very fun. Well, I'm here to show you the contrary, at least for astronomers and astrophysicists. I can't really speak for other scientists. Given that space is so absurdly, crazily, ludicrously, unfathomably, stupidly big, there are a lot of different phenomena and whatnot to be named. And given that the main thing astronomers and other scientists is to prove that they're fun and sculpt their image to please the public, because they really do care what you think, astronomers came up with some absolutely phenomenal names for phenomenal phenomena. Okay, maybe not very phenomenal phenomena or phenomenal names. Also not all phenomena. These are mostly just fun names for random astronomy stuff. Anyways, here they are. First, I want you to pronounce this word. Alright, time's up. The word is pronounced syzygy. Syzygy is also known more commonly as a conjunction, which is when three celestial bodies approximately line up with each other. The Great Conjunction in alignment of Jupiter, Saturn, and Earth, therefore can be called the Great Syzygy, though I'm not sure that'll catch on. This alignment, by the way, happens about every 20 years, yet especially close alignments such as the one of December 21st, 2020, happen once about every 4 centuries. Moving on. Next on our list of cool and funny names is spaghettification. This absolutely is an actual term. I cannot make this up. Despite how harmless or tasty it may sound, though, I suggest you don't do it. If you want to find out why 9 out of 10 doctors do not recommend you doing this, check out my previous video on black holes, which I suppose I will leave a link to in the description, and it'll probably pop up above my head too. Continuing our list, we have the word quasar, which is short for quasi-stellar radio source. Just admit it, this is a cool sounding name. When quasars were first discovered, they were just identified by their emission of radio waves, hence radio source, and when they were finally photographed in visible light, they seemed only like faint stars, hence quasi-stellar. Yet looks are certainly deceiving here. This too has to do with black holes and the fact that it is indeed powered by a black hole at the center of very distant galaxies in their early evolutionary stages. The black holes form a disk of material falling into it called an accretion disk, which heats up a lot, creating an insane amount of energy. It's really crazy. It's absurd. The most luminous quasars are on the order of 100 trillion times the luminosity of the sun. Naturally, this fact makes quasars a subset of the aptly named active galactic nuclei, or AGN, which also contains blazars, which are literally just quasars pointed directly at us. Also a cool sounding name. And Seyfert galaxies, which contain an AGN that doesn't outshine its host galaxy. The next name also has to do with galaxies. Starburst is not only a candy, but a type of galaxy. Starburst galaxies are galaxies which undergo an intense amount of star formation. M82, the cigar galaxy, is a notable example of a starburst galaxy. Moving along, perhaps on a segue, we have some acronyms. Astronomers, for whatever reason, love their acronyms and will take any opportunity to make them fun. For example, there's this thing called a hot dog. Hot dog here stands for Hot Dust Obscured Galaxy. First hot dog was found by, naturally, another acronym, WISE, short for the Wide Field Infrared Survey Explorer. Hot dogs were believed to be the very early stages of galactic evolution before quasars, before the surrounding dust is pushed away or absorbed by the ensuing quasar. The other reason for this distinction is probably just so astronomers could call something hot dog. The realm of astronomy acronyms also brings to us WIMPs and MACHOs. These stand for Weakly Interacting Massive Particles and Massive Astrophysical Compact Halo Objects, respectively. These are mainly 2 candidates for dark matter. I will go into way more depth in a later video, but essentially, dark matter is what we attribute to the extra gravity we see affecting galaxies and galaxy clusters. WIMPs are matter that really struggle to interact with anything else, making it extraordinarily hard to observe, and therefore is not matter we can directly measure. Similarly, machos are matter that is extremely hard to detect by nature of those objects. Machos include rogue planets and black holes, both of which do not emit light. making them inherently hard to detect and be counted directly. Despite us not knowing what it is, we think dark matter makes up 85% of all matter in the universe. We find this out through relatively simple orbital mechanics, which we've used and understood for a long time now. There's beauty in simplicity. Astronomers obviously know that because despite describing some things in the most complicated of terms, so great acronyms may be formed, they have some extremely simple and straightforward names. The first naming system I like to discuss is, again, with black holes, specifically the term supermassive black hole, which, as the name suggests, describes a black hole that is, you guessed it, supermassive. Different astronomers put different ranges on masses for supermassive black holes, but the most common range of masses is between 100,000 and about 10 billion solar masses. Well, aren't there black holes that are bigger than this 10 billion solar masses, you ask? Why, yes, there are. The largest black hole discovered is found at the center of the aforementioned quasar, aptly named TON 618, or TON 618. In fact, that is named TON is technically unrelated, but it works well here. Being in the tens of billions of solar masses has put it into another class for some astronomers, ultramassive black holes. But of course, it gets even better than that. It's possible that there's no upper limit to the mass of black holes. For black holes on the order of 100 billion solar masses, both the full name and the acronym are great. These black holes are known as SLABs, which stands for stupendously large black holes. I cannot make this up. There are more similar terms as well, like, for example, very massive stars, VMSs. This is absolutely a technical term for stars above 100 solar masses, which is definitely very massive and actually an important distinction because it affects how we view stellar evolution. Moving even closer to home, we have the types of planets in our solar system. The names are so simple. Particularly, Jupiter and Saturn are deemed gas giants, as the name suggests. They're made almost entirely out of gas, and they're big. Uranus and Neptune are icy and big, so they're called ice giants, of course. Finally, I'd like to land on Earth again, where, of course, we're still looking up. We're interested in some of the instruments we use to look up here, though. First up, we have the Very Large Array. This is, of course, a very large array, which consists of radio antennas over the area of 3 acres in Socorro, New Mexico. An even more straightforward and simple name is the Square Kilometer Array. Granted, this one has not yet been built. It will be built in the Southern Hemisphere with core stations in Australia and Africa. Some of the best and simplest names for traditional telescopes includes the Very Large Telescope, consisting of 4 telescopes, each with an 8.2 meter aperture. The Large Binocular Telescope, which is, naturally, 2 telescopes, both of which are 8.4 meters of aperture. Telescopes under construction include the 30-meter telescope, with the total aperture of 30 meters, of course, and the European Extremely Large Telescope, which, obviously, is being built in Chile and will have a total aperture of 39.3 meters. The final telescope, and also the final term/name in this video, is the Overwhelmingly Large Telescope. Of course, they made the abbreviation OWL, OWL. This was cancelled due to the absurdity of building and transporting such a telescope, as well as the cost. The OWL was proposed to have a singular aperture of 100 meters. This is a diameter of more than the length of an American football field. That would have obscene light gathering capabilities, allowing capture of objects 1,500 times fainter than the faintest object the Hubble Space Telescope has ever detected. The cost would have been crazy as well at $21 billion. Efforts are now being focused on the European Extremely Large Telescope. Well, we did it. We got through the video. If you have any questions about any of the terms, or you think I missed some terms, let me know in the comments. Remember to like, share, and subscribe to spread more awareness about space. And of course, remember to keep